Hey guys, hoping all is well with everyone. So in this video, we are going to be looking at our question of the day, and this one revolves around 8th grade level math. It is under the topics and concepts of comparing linear and non-linear functions, but also looks at differentiating between linear, quadratic, and exponential functions. So this comes from an online math program, and the question states, answer the questions below to determine what kind of function is depicted in the table below. So we're given a table of x and f of x values, and we're given two boxes with multiple answer choices, and we are asked to decipher what function is above and why. So the answers that you have for what type of function it is going to be linear, quadratic, exponential, and none of the above. And the reasons for the second answer box are going to be the first differences are constant, second differences are constant, and the ratios of successive y values are the same, and none of the above. I didn't include none of the above for this particular question because it's not an answer that applies to either one of the correct answer choices for the boxes. So when we look at this question, the verbiage of the reasonings can be a little daunting because it may not be something that we're familiar with, but what I did is kind of come up with a little flow chart that we see on the right hand side here, and we're going to talk about it step by step. So when it talks about the first and second differences, it's talking about the y values specifically. So when we're looking at this table of x and y values, we're not going to concern ourselves with the inputs at all. We're not going to focus on the x values. They're not important here. So what we're going to do here is to find the first differences, we're going to go ahead and find the differences between each of the consecutive y values that are given to us in the table. So the difference between -5 and -7 is -2. The difference of -7 and -13 is -6. The difference of -13 and -23 is -10. And the difference of -23 and -37 is -14. So these are the calculated first differences. So I'll actually put these in red so we can kind of highlight them. Now, as you can see upon observation, these differences are not the same. So if they were the same, they would have the same exact difference. So it would be -2 from -5 to -7. It'd be -2 from -7 to its next one, which would be -9, if that was the case, and then so on and so forth. That would be if the first differences are constant or were constant. Now, what that would mean from a function type revelation would be that it would be linear because it maintains that the first differences are constant, which means that the y values have a common difference. So that would be indicative of a linear function. So in our first part of the flowchart on the right hand side here, if the first differences are constant, the function is linear. If the first differences are not constant, which is our case on the left, we have to do some further investigating and digging to figure out if this is a quadratic, exponential, or none of the above situation. So now that we've calculated our first differences, to calculate the second differences, we're just going to take the differences of the first differences. And remember, it's consecutive. So the difference from -2 to -6 is going to be -4. The difference between -6 and -10 is -4 as well. And then, lo and behold, the difference from -10 to -14 is -4. So these are the calculated second differences for this table. So because these are constant, we can go ahead, so I'll use this here. So now you guys can kind of see visually the differences between how you calculated the first ones, the first differences, and the second ones. So because the second differences are a constant, that is going to be correlative to the fact that this is a quadratic function, okay? So on our right side here, we say that if the second differences are constant, the function is indeed quadratic. If the second differences weren't constant, we would then have to do a little bit more looking into something beyond the second differences. So what we would do next is we would look at these second differences and see if they differ by some type of common ratio. So to kind of illustrate that, if the first difference was -4, and the second one was -12, and the third one was -36, those all differ by a common ratio of 3. That would be an example of an exponential function because the consecutive or successive y values are different by a common ratio of some type. Keep in mind that the common ratio that they may be differing by does not always have to be an integer. It could be a fraction or a decimal as well. So one of the things that I like to give kind of as a help kind of strategy is instead of looking for something that is multiplicative, you can work backwards too. So if you had -12 here and -4, you can divide -12 by -4 and you can get 3. Sometimes doing the division and working backwards can help you instead of trying to figure out the multiplicative going in the forward direction. But the final answer for this question is going to be that this is a quadratic. Oops. This is going to be a quadratic function because the second differences are constant. Okay, so and this is a strategy you can use for kind of any question type relative to this, especially in this kind of realm of 8th grade math, if because we know now the properties and attributes that relate to the function type in terms of the y values that exist in a particular graph or table. Now, if you wanted to as well, if you wanted to go like above and beyond, you can graph this as well. The only thing that's kind of unfortunate about this table in particular is with quadratic functions, they're very symmetrical around their line of symmetry. So unless you were given that line of symmetry in the XY table, you're not going to see any symmetry revolving around that line, and you're not going to see any kind of symmetry in the Y values either. So if it helps you, like, you can plot the points in a coordinate plane system and kind of see what the behavior of the graph looks like. It can be helpful, but I would say it has its limitations, okay? But I hope this helps you guys out. If you have any questions, please, again, don't hesitate to reach out and ask. But I hope you guys have a wonderful rest of your day. Take good care and be safe. Bye.